Welcome to EPARTRADE Live. These webinars are awesome and they're fun and they're give a ton of information and insight. It's kind of like having a TV channel for the racing industry. So this is working out really great. Today's webinar is fine-tuning your engine building process, machining tips that make a difference. So we have son and veteran Bob Dolder here, and then Chuck Lynch, AAR, which is Engine Builders Association, Director of Technical Services. I'm your host, John Kilroy, and I'm Chief of Content and Audience Development for EPARTRADE. And before we get to the meat of the webinar, I just want to say a few quick words about EPARTRADE. We're in our third year of business. We're strictly a racing industry company. We're not active anywhere else. And the executive team of EPARTRADE has decades of experience each in the racing industry. So we know this business. And basically, we've tasked ourselves with providing the worldwide racing industry as a whole with an online strategy. So other industries have that, and it's time that the racing industry has that as well. So it's kind of three-pronged. We have EPARTRADE, where you can use our smart sourcing technology to source racing technology and suppliers. Not an e-commerce site, but you can find information and who you want to contact within the platform and contact the supplier within the platform. This is easier, it's no charge, it's very productive, and it works. So use EPARTRADE to source technology suppliers. And then we have these webinars, EPARTRADE Live, and they're going great. And it's something new, it's just taking off, and we're glad you're here. And then get ready for Online Race Industry Week, November 30th through December 4th, so Monday through Friday. With the racing trade shows canceled this year, EPARTRADE was poised with all the resources to step in and provide you with a trade show experience online, so it's safe. And we just can't afford, as an industry, we can't afford to really miss that opportunity that we have every year to share information, contemporary, updated information, and then kind of review and shop the 2021 new product line introductions. So that week, you'll be able to go to EPARTRADE and catch up with the 2021 new product line introductions and just shop around. We already have hundreds of companies signed up with showcases, and we're having new suppliers sign up every day. We have 50 sessions of tech webinars already confirmed. So we just got to lock them in a schedule, who's going to be at Tuesday at 10 a.m., who's going to be Thursday at 2 o'clock. And we're doing that now. We should have a schedule for you next week. We're working with Racer.com to provide some webinars that are basically state of the industry kind of webinars, or also just for fun. So you can have lunch with Brian Herda, and he'll talk about developing a winning race team. We'll have Chip Ganassi sharing his thoughts on the racing industry today. We have now Don Prudhomme has agreed to kind of work with us. So we have a dinner with Don Prudhomme, or a happy hour with Don Prudhomme, one of the all-time greats in American racing. And to me, he's one of the coolest guys ever. So I'm sorry, Steve McQueen, Prudhomme's cooler. And we'll have a lot more going on. We have one login for the whole week's content, so it's very easy for you, no charge to attend. And then for you guys kind of running your engine shops, you can invite the whole team to participate. They can all have a login. Just have them all registered, and then we know who everybody is and how many people participated. But use it as a training tool. And also invite the whole team to go on EPARTRADE and shop around and get their perspectives on new products and new technology. And then the great thing about the online experience is that no airfare, no hotels, none of that. You get to stay in your place of business and just kind of attend right from your desk. So that's Online Race Industry Week. We ask you to sign up sooner than later, so go on today and get your Zoom login. And then quick housekeeping notes on kind of what we're doing today. So all the webinar attendees have been muted, and you're not in video, so there's no distractions. But we do want your questions. So there's a chat option at the bottom of your Zoom screen, and you can type in your question there. I'll be reviewing it, and Bob and Chuck can review it as well, and we'll get your questions answered. So just start now and give us your questions. This is a very sophisticated audience of professional race engine builders from around the world. These guys can handle your questions. So just kind of let's go and get your questions answered. So our speakers today, first of all, it's great to be working with Sunnen. So hello to our longtime Sunnen friends, Bob and Wolf. Good to see you again in this environment. I've known these guys for almost 30 years now. It's unbelievable. Sunnen is not just a great machining company, but a great racing industry company. So they run the Engine Charity Sweepstakes at the PRI trade show, just a great annual trade show for the racing industry. Has raised tons of money, tons and tons of money for the Petty Family's Victory Junction Gang camp for kids with terminal or debilitating illnesses. If you're a race engine builder, you can't think of going to a real racing trade show without thinking of Sunnen. I've been to the Sunnen facility, just one of those great Midwest American companies with a long history, solid as a rock, almost 100 years old. And now they've grown and become a brand long recognized and valued all around the world. So #1 in name and honing. They do business on a global scale. And I counted them up. They have offices in 15 countries. So a leading player in other industries as well as racing. So it's great to have Sunnen here. Bob has worked for Sunnen for a long time. He's been in the engine rebuilding business for 48 years. He's worked as a parts counterman, worked in the machine shop, taught at a community college, sold machine shop equipment, and presented numerous workshops, webinars, and seminars already. He spent the last 21 years of his career working for Sunnen Products Company, with his last position being the automotive sales and application manager for Sunnen's line of honing machines. Bob's retired, but he's still working with Sunnen. Vast sea of knowledge with Bob, so we're glad he's here. Then Chuck Lynch has been in the automotive aftermarket for over 30 years. He served in the Marine Corps as a service repairman with general support and maintenance, but rebuilt engines, transmissions, and rotating electric components for fleet service. After leaving active duty, Chuck spent 20 years in the production engine rebuilding segment, Jasper Engines and Transmissions. And then he's worked as a field service technician for Rottler and a PER sales engineer for Molly Cleavite. So just a great history within the racing industry. Thank you guys for joining us and sharing this time with us. And I have questions for you, but maybe there's a place you'd like to start when it comes to machining strategies for race engines. Bob, do you want to kick us off here?
Sure, happy to. And thank you for the very nice, kind words about the company that I work for. And I'm still consulting. I can't get away from it. It's in my blood. They say Sunnen salesmen always have honing oil in their blood, and I still have it. Thank you again. But we are very much, some people have said that we're out of the automotive engine rebuilding business, and that's the furthest thing from the truth. There's several parts on an internal combustion engine that needs to be honed, and we feel that we're the experts in that field, and we continue to do that. We have representatives out there every day, and happy to field any of your questions. You can still contact me via my email, which is bdolder@sunnen.com, and ask me questions. And I still have my computer and my cell phone from Sunnen Products. So I'm readily available. May not get back to you as quick as I used to, but I'm sitting there looking for those questions, and I'm happy to answer anything I can to help you. And again, thank you very much for the wonderful introduction.
Thank you for being here. Chuck, do you want to kick us off as far as what we're going to be discussing today?
Okay, so I work on the tech line and have a lot of history in the automotive machining. Kind of my passion's been making chips fly. So anything that you would want to ask about machining, tolerances, and the interrelationship to the parts that engage them, that's pretty much what we do on a daily basis at AERA, is provide technical consult on the engine machine shop side of it. Now, over time, as we've become more involved with the ancillary components that bolt on, it is diverging into controls, turbos, fuel systems, things of that nature. But primarily, we're out to assist the engine machine shop.
Okay. Bob, in all your years and watching people hone their engines and coming to this webinar, is there an initial message that you want to give to the race engine builders out there, your first piece of advice?
In today's world, the specifications are so much tighter than what they were 48 years ago when I first began this. It just keeps getting tighter and tighter, and your machining processes are very, very critical to that. I would encourage everybody out there to have ways of measuring and measuring correctly, as well as a good quality machine and good quality tooling. A lot of times I run into situations where customers call me and they're having all kind of trouble, and the bottom line is their tooling's just wore out. So we need to pay close attention to that. I think that's very, very critical in today's engines, racing engines in particular, because we're going to the maximum power that we can get out of that internal combustion engine. And to achieve that, you need to have that specification and that machining process done correctly.
Chuck, do you want to add to that? When you came to this webinar, was there one kind of initial message you wanted to share with race engine builders?
The thing with race engine builders is they're very accustomed to holding tight tolerance, and the modern engines are emulating the race engine world. So EcoBoost or something of that nature, the diesel engines, those guys have been used to working in a platform where that they know that all the piston heights are within a couple thousandths. That didn't used to be the case, as Bob mentioned earlier. If a piston height varied 20 thousandths in a bore or something, they didn't really pay much attention. We still do have struggles and challenges with the manufacturing of crankshafts, connecting rods, that we have stack up tolerances that we have to deal with. But the performance guys are pretty crafty and they deal with that type of stuff, but it does make a difference. We take a lot of calls on resurfacing cylinder heads, and the importance of keeping balance between combustion chambers. If you have a warped head, you need to really analyze that. What impact is that going to have in your performance and reliability? If you have castings that are too far warped or something, you don't see that so much when you're putting all new components together, but there is a segment of nostalgic muscle car building, and you need to put forth the effort to make sure that everything is uniform, well balanced, so that you have a strong, reliable, balanced engine. So, okay.
And then again, if you put the cursor down at the bottom of the Zoom screen, there's a chat option, and please write in your questions, and then you can be as specific as you want, as technical as you want. So here's a question. If a block has been align bored, should it still be align honed?
Yes, I'll go ahead and start this one off. So if you think of precision, anytime you're making components, honing, grinding, lapping, those are all processes that are extremely precise. They can control surface finish well, geometry, cylindricity. So from that component, yes, it's ideal to align hone even when you bore. The align honing can give you good surface finish, but the bearing really likes that because I can increase the amount of contact from the backside of the bearing. I was working with a bearing engineer many years ago and was asking about, hey, do we really need to hone these housings when we machine these connecting rods? And he said, yes, please do, because what you do is you create traction for the backside of the bearing. So you create a surface finish. The more contact I can have with the back of that bearing, the better it's going to stay in place. Most of the performance guys know that the locating tang on the back of the bearing it's not a lock. It doesn't hold it in position. It's the crush of the bearing. The bearing's actually bigger than the bore that it's in, but it's the contact. Now, surface finish matters because if you get too aggressive with your surface finish when you hone or bore, you can allow a lot of oil to get behind the bearing. If you have too much film thickness and then it cooks, it's called coking. When that happens, it's turning to like glass. Well, glass is not a good conductor. It's more of an insulator. So your bearing surfaces can operate at higher temperatures. So you do want to, again, improve the contact surface area, dissipate the heat. And again, it's about the most precise surface that you're going to create is by honing.
Bob?
The only thing I would add to what Chuck has said is when you're line honing versus line boring. Line boring, you can get off a little bit one way or the other, where when you're going in with a line hone, you're correcting the tunnel so it's straight from front to back. And that's very critical. The other thing that I would add to that is, you know, you can make, the best way to put this is make sure that you know what you're doing when you're line honing, because you can create a worse situation if you don't. There's a lot more to line honing than just sticking a mandrel in and stroking it back and forth. There's feed pressure, there's oil, there's things of that nature to really keep it straight. And the mandrel can go, you know, it make high spots and low spots if you do not stay on top of keeping that mandrel true. So those are very, very important issues when you're line honing versus line boring.
Okay. Then we have a question from the audience. Rumor has it that some engine builders refuse to assemble engines on a stand as the block or the stand could distort and throw off measurements. Any basis for that? Have you ever heard that before?
That's a new one on me. I'm sorry. You know, I know that, you know, back in the day when we first started to, you know, do machining on blocks, is we would hook everything to it that we possibly could. We put the bell housing on it, of course, torque plates, you know, anything that could go on that block that would distort the way we machine it, that would happen. But I honestly have not heard that the engine stand itself could distort things.
Okay. That's good to know that you guys haven't heard about it.
No.
Here's another question. I'm used to doing HD motors that need torque plate for boring and honing cylinder for assembled distortion. I'm now doing one long 100 snowmobile racing. Do they need a torque plate?
So anytime you can apply a torque plate with a head gasket, so forth, and you recreate that distortion that's going to happen when the engine is assembled, you're going to improve the end product. Now at the OE level, you get this argument a lot though. Well, the OE's not doing that. It just depends on what you want. What do you see as your satisfaction level? You know, quality is in the eye of the end user, right? What's their, it's all about perception. I want it to be to this specific level. You will see improvement with torque plates. You don't necessarily have to use the torque plates. If you're going to accept a given number of leakage, then fine. But you know, the simple answer is you should always see an improvement. Now there's some caveats to that. You have to make sure that you do your homework, and because how many heads have a big hole in the center? So what you really need to do is bore and hone a cylinder, then apply the gasket you want to use, torque the head to spec, take all the measurements and see what that yields, then put a torque plate on, and then you have to kind of play around with the torques and what yields what the head gasket gave you. And that's where a lot of people miss it. They automatically want to throw a torque plate on and torque it to whatever the specification for the head is. That doesn't necessarily work. Sun has done a ton of research on that. They actually have an inkometer or a pat gauge, and they can tell you what the bore truly looks like, because a dial bore gauge can't really tell you out of round. It's just, there's no reference point. The dial bore gauge tells you the distance from A to B. So you can't see if a cylinder looks like an accordion, if you have a banana shaped hole or something of that nature. And that gets into the tooling of the honing part of it. But a torque plate will create all of the stresses. If you're using the correct head gasket and the correct fastener load, it will make improvements.
Anything to add, Bob?
No, I think Chuck covered that pretty well. Again, just what, to reiterate what he said is, it's gonna make a difference, and it's all in what you want. In reference to an OE, original equipment manufacturer, not using torque plates, remember they're doing nothing but brand spanking new product, and it's important for speed for those guys, and that's why they eliminate the torque plate when they're building a brand new engine. That's one of the reasons.
Okay. Another question is hot honing still a thing?
I'll take that first because we really got into it quite heavily for a long time. And the reason for it was, we want to recreate again what that engine is doing when it's running. And it's a lot of work, first off, because you got to heat the engine up, then you got to use two separate dial bore gauges because one heats up and throws the numbers off, so you're going back and forth and back and forth. And the bottom line is we have created in the racing industry a much better block with compacted graphite and things of that nature that eliminates that hot honing process. Now, that being said, I don't know, there are still a few people out there with aluminum blocks that they're still using the hot honing process, but not like they used to.
Is that kind of what you're seeing, Chuck?
Absolutely. You look at the 90s and we were doing, vibratory stress relief of castings, hot honing and so forth. And you just, not so much anymore. I think we have better engineering and development packages and software, and we can predict and forecast for some of that. And we, as Bob said, we do a better job making our blocks, better materials, better structural design, understanding and intent before we get to that point.
Okay. Another question from the audience. And again, you can type in your questions at the bottom of the Zoom screen. There's a chat option. Just open up and start typing. What is your opinion on 3-point micrometer type bore gauges versus a traditional 2-point dial bore gauge at the 0.0001 inch increments? Any thoughts on that, Bob?
I truly believe that the 2-point for that, Sonnen makes, and of course, there's also a way to centralize that point, so to speak, with the feet that are on the outside of the dial bore gauge. We've always had very good success, not just in the automotive internal combustion engine, but just as well with some of the really, really tight tolerances that we see in the industrial world. 3-point probably in some applications, not necessarily the internal combustion engine, but in some really like 50 millionths or better tolerances, a 3-point may work a little better. But I wouldn't recommend it for our industry. If you really want it checked right, like Chuck said earlier, check it with the pad gauge, and that'll tell you the real story and what real cylindricity is. So,
Chuck, anything to add to that?
I think Bob pretty well hit it. 3 points is easy to use because 3 legs never wobble, and it's easy to kind of find your place in the bore, but it can only average. I have quite a bit of experience with the 3-point gauges, and you're just averaging. If you think about an egg, you can make it contact, but you just don't get the exact result. And we may get into this further on, but if you look at orders of geometry, it gets to be a real challenge with many bore, or you can have a cylinder that actually ultimately looks like a triangle, a clover leaf, things of that nature, and they can give you headaches when you're dealing with the effect, whether it's cylinder leakage. Kind of gets back to the torque plates, but most of the gauges will still give you like a dial bore gauge, or if you were to mic a valve stem that has lobing, it'll still maybe mic, say we're going to use the number 5/16, 312 thousandths. It'll mic that as you rotate it, but it's actually just, you're always hitting on the high spots. You can't catch the low spots. And, 3 points in the cylinder, just, it adds complexity to trying to diagnose what the problem is.
Okay. All right. Here's another question. Is it okay to mill all blocks and heads to multi-layer shim MLS gasket specification?
Okay, I'll run with that one. It's risky. As gasket manufacturers have improved the manufacturing process, and actually one of my team members, he's a gasket design engineer, and I challenged him to this question not too long ago because it came on the tech line, and he's like, definitely you need to look at the construction of the gasket and stick to that. MLS gaskets, they have a lot of head lift off is what they're trying to accommodate. So you're working with a spring, and your fasteners, torque to yield fasteners, or stretch bolts, as they're sometimes referred to. So, you're lifting the head off, and these things are help bring it back to home. But you also have lateral expansion of castings. Well, those multi-layer steel shim gaskets give you an opportunity for that stuff to all kind of orbit around and not scuff. If you were to use a cast iron block, aluminum head, and conventional fasteners, you kind of need something to keep that gasket put. So you need a little bit of traction. So they're going to usually be a little rougher on the iron block than they are on the aluminum head, where they want it to slide on the gasket. So you're better to really follow the gasket manufacturer's recommendations. They are doing things like we call heated pre-flattening, where they put the gasket in a big flattener. It's a big platen. It's kind of like the old steam presses for clothes. So they put the gasket in there, apply temperature and load, so that you don't have to go like the old days and run it for so many hours or so many minutes, get it at operating temperature. It used to be common to say, okay, after an engine runs a certain period of time, you retorque the gaskets and rerun the lash. So they've tried to get away from that, but just by saying, hey, let's just mill everything all the same, it's risky. I wouldn't advise it.
Go ahead, Bob.
Oh, I was only going to say Chuck hit it on the head. I don't have anything to really add to that.
Okay. What parameters do I need if I'm going to order a profilometer for bore finishes?
I would recommend that you have the following that you can do: RA, RPK, RK, RVK, and then have the ability to also check MR1 and MR2. Those are really the parameters that we need in the modern engine today, and that's as critical as a dial bore gauge would be today, because the surface finishes have become to the point where we really need to measure them beyond using your fingernail and say that's good enough. But just to elaborate a little bit on that, your RPK is a reduced peak height. Okay, that's the top. That's what the ring's going to see when the motor first fires up, and that's generally going to be a low number. And then your RK, that's your core roughness. That's basically what that ring's going to ride on after the motor is broke in. Your RVK is your reduced valley depth. RVK is very important. That's what's going to hold the oil. It's and that's where we need it to be. RVK numbers have actually come up a little bit compared to when we first start measuring them, especially on some crazy applications on some of these diesel motors out there. Your MR1 would be your peak material ratio. That's going to be a percentage, not a number. It's going to tell you, 5% or 10% or 80%. That's going to be a percentage. Your MR2 is your valley material ratio. Again, that's a percentage. So it's very, very important. If you're going to be a modern day engine builder, it's just as important to have a profilometer in your toolbox as it is to have a 0 to 1 inch micrometer. So yes, it's an important tool.
Very good. Chuck?
Those are very good points, Bob. And that said, then if you have the profilometer, then you're going to be able to measure your gasket surface finishes, your crank housing bore, your can bore finishes, everything else. It matters in every part of engine building. But as you pointed out, it's just as important as the dial bore gauge or the hone head itself. I just did an article in Engine Professional magazine last quarter speaking to some of that. And I did reach out to Sonnen and Rottler and everyone that's, in this. And we were talking about some of the things that people typically don't think of. So they want to know, hey, what abrasive do I get the surface finish with? Well, as you mentioned earlier, Bob, compacted graphite. What's the hardness of compacted graphite? What about the ductile sleeve you're going to use? What about a block that's fiber reinforced aluminum? So you really need to know, because that's one part of it. Now, what about what's your filtration system for your home? When I hone, I create swarf. So my cooling system will pick up trash. If I don't filter it well enough, I blow that trash right back in to the cylinder that I'm honing. So that's a variable. Am I using a synthetic based coolant? Am I using petroleum based? Am I using brushes? So, you start to think about all these variables. Do I remember where I was at when the phone rang and it interrupted me? So variable. Well, if I got a profilometer, I can still measure. If I don't have a profilometer and I haven't tracked my variables, then I got chaos. So chaos is not good.
Sure isn't.
Very good. Another question. Can I adjust oil clearances by honing rod and main housing board diameters? Bob?
That's dangerous. Don't do that. Because the bearing has to have crush on it. And the minute you start taking some of that crush away by opening up that housing to give you more clearance, you're asking for trouble. You should always, whether it's a connecting rod or whether it's a main bore, stay within the manufacturer's specifications on that. That's the only way to do it. Now, with a cracked rod today, of course, we can't cut the caps and cut the rod anymore. But what is available out there is some oversized bearings, and that's okay because it's still creating the correct crush. So it's very, very critical as far as I'm concerned, and that engine is concerned, I should say, that it has the correct size in that housing bore. It needs to be right.
Chuck, just check with you. Anything to add on that?
Yes. You don't know where the bearing supplier is on the material that they use for the steel backing. What is their crush height tolerance? You got eccentricity, you got crush relief, you got crush height. We don't have the tools to accurately measure that in the machine shop typically. So if they tell you this is the bore diameter range, be safe and stick to that.
Yeah.
Very good. Here's a question from the audience. Again, just use the chat option at the bottom of the Zoom screen, write in your question. You mentioned vibratory stress relieving. Is it useful for aluminum blocks? Bob?
I'll let Chuck take that one.
The process has kind of lost favor. It was very, again, in the 90s, the early 2000s, it was pretty popular. It was recommended for about any kind of material. Aluminum, you still have induced stresses. Oftentimes you have cracks and castings or whatever. So it was some induced stress that relieved itself. Now, when you have aluminum block, then you usually have cast in sleeves or maybe pressed in sleeves. More lately, we've got modular integrated deck sleeves, but back at that time, there was a lot of just cast in sleeves. It looked like maybe it had a spline or a string wrapped around the sleeve. So if you could do some vibratory relaxation and any of those stresses would then really show themselves, and you may have to go and hone the cylinder or make some changes. There's probably not a downside to it, kind of like the if you deep freeze the parts. So anytime you can accentuate that stress or relieve that stress, then it's kind of like running the engine first and then go and touch up all the specifications. Now I'm no longer working with a green casting that may move around a lot. So downside to it, I can't really think of any except for time and equipment.
Yeah, okay, that makes sense. There's a question from our friend at 66 Salvage Restoration Speed Shop. I'll just read it. Talking racing, let's talk about the fine tolerances of racing block specs versus average block specs. Example, tolerances of dirt track 602 crates versus a mud bog truck versus your regular built blocks for average drivability. Does that trigger something in you guys?
Well, I guess I would, maybe speak to oil clearances and engine speed dictates some of the decisions that you make there. I mean, power output, heat, you would fine tune the pistons, but then you should really talk to the manufacturer, because what about coatings? Do I have a coated crown or just coated skirts? What kind of rings am I going to use? Rings are underappreciated for how much of a heat sink they are. So as we reduce the axial on rings, we increase the temperature load that they have, so you can have micro welding and things. So I guess it would have to be more specific to that particular build and where it's going to be, RPM wise, horsepower wise, duty cycle wise. Okay, so it's a mud bog. Are all the mud bogs going to be the same distance? So sorry, that's probably not a great answer, but that's the challenge.
Everything's so individualized in racing, I mean, and it's getting more micro all the time.
I'd like to add just one little thing to that, if I may. The Sunned Products, for close to over a year now, we have been working with a company that is working on a process. It's not a coating or anything like that. It's a process that impregnates into the surface, and it's honing applications, and that's why we're involved with it. I would keep my eyes open here in the very near future, and when we officially come out with it and see what this process does, but it will definitely help in the engine build. It's a friction reducer is what it is. That's what it does. Okay.
We'll share that story on EPARTRADE. So when it comes out,
okay,
it'll be on our homepage.
Absolutely.
Will it be by the first of the year, you think?
I would, yeah. Again, I'm saying yes, and I'm just a consultant right now. So, but I would say yes, and this is going to push Sunned to work a little harder on it. Okay.
We look forward to that.
Thank you.
How much material can be honed with single pass valve guide tooling? Bob?
The normal process for single pass tooling is to remove right around 1/2 thousandths of an inch, 5/10. I know people out there with single pass tooling try to remove more than that, and it really depends on the material. It's like any kind of process. What's the material made out of? And but in my experience, if you try to go more than 1/2 thousandths of an inch with a single pass tool, you're setting yourself up for trouble.
Chuck?
Yeah, I would just follow with what Bob shared there. When I was in the shop, I worked with Sunned on this on a couple of different occasions. So good products.
Okay. Another question. What creates the best overall bore geometry in a honed cylinder? Bob?
There's a lot of things. First off is, and importantly, is tooling. The tooling has to be correct. The abrasives, what abrasives are you using? They need to be correct as to what kind of surface finish you're trying to come up with. And that all relates to overall geometry. The feed speed and the feed itself, the speed of the tool, how fast is it is stroking, and what the tool speed itself is. What type of coolant are you using? Are you using oil? Are you using a synthetic coolant? What is the block material made out of? So again, you know, these are all things that are variables today that need to be addressed. And are you dealing with a virgin block that's never been worked before? Or are you dealing with something that's been work hardened? And those numbers can vary. A Rockwell hardness test is something that, you know, some of the machine shops are using today just to find out that information and start building a log as to, okay, this is how I deal with that particular material. So it's some of it's trial and error, I would say, but most of it is you need to just build, you know, exactly how you're going to approach that application. It's application, application, application.
Makes sense. Anything to add, Chuck?
No, I think that covers it.
Another question. I'll just read it. We have primarily used 3-step cylinder honing processes, 220 to 280 brushes, vitrified, but have heard of recent changes to a 2-step process, 180 or even 80 grit and straight to 400 grit. Any preferences in either process? Chuck?
Again, I would go back to what ring is going to run against that cylinder, and then, you know, let the profilometer tell you what the values are. The ring is really going to dictate that. You know, Bob has mentioned in the upcoming process that's going to reduce friction by the cylinder process, but, you know, rings like TLC, titanium nitride coated, gas nitride, the steel rings, they don't have the moly coat in the face of the ring, which is absorbing a lot of oil. So it has to be in the bore. So you really need to know what ring you're running against the bore to actually make that decision. Now, in the diamond world, there are a lot of folks that are using one diamond abrasive and then a brush. It's very common, happens all the time. But again, I hate to say, hey, you should do this abrasive and not know what ring you're intending to run against it.
Yeah, as far as surface finish, like, you know, to say basically what Chuck just covered very well, is there's the application, again, depending on what you're going to do with it, what type of ring you're going to have, again, what the hardness of the material is that you're honing. I mean, in today's world, the diamonds do make better geometry. I mean, any super abrasive period, whether it be diamond or whether it be CBN, it's going to determine your geometry, and that's what you're looking for, the best geometry and the best surface finish. You know, your typical numbers on 90% of the applications, you're looking at an RPK of like 10 to 15, and your RK is 40 to 45, and your RVK is 50 to 55. And then there's beyond that, I mean, you get into some crazy diesel applications, and you may have an RVK that's 100 plus. So again, application is important, and then building the process from the application.
Very good. Chuck, just check with you. Anything to add?
No, I think that covers it.
When installing new pistons on a connecting rod, should the small end be honed?
That was a very large mistake made back in the days of pressed pistons on connecting rods, because pistons, generally new pistons, oversized pistons, come with a bigger pin, 5/10 usually larger. So we would use an oven to heat up that connecting rod so we could push the pin in, or we use a press, and all you're doing is stressing the small end of the connecting rod by doing that. The other thing that you need to be careful of today is, if in fact the pins are a little bit bigger, but you also got a bushing in that rod today, where most of them today are full floating, you always need to check it. And it's very, very important to do that, is always check both your piston as well as your pin and your connecting rod, all three of those. Sunnen does make a very good gauge for that, our AG 300 gauge, AG 400 gauge, and it's easy to set up to be able to check with just using the pin to set that gauge up. So yes, to answer your question, we need to be aware of it, we need to check it, and in most cases, we need to hone it.
Yeah, very good. Chuck, anything to add?
The only thing I would add is, performance world, most of the stuff's full floating with retaining locks and so forth. And the automotive sector has gone back around, so things kind of go full circle at times. But with powder metal connecting rods or forgings that are getting near net, they get really skinny on the small end. So there's just, less inertial mass up on that end. They have reduced how wide the top of the connecting rod is. And then the PEM products, since there's not a whole lot of mass around the pin end, more piston pins have come loose. So you're seeing the OEs are even going back to full floating with retaining locks. So the press fit thing is greatly diminished, which means it's probably even that much more important that you really look at that pretty closely. I'm speaking from experience, seeing several applications that we redesigned the piston even when they were press fit, because so many pins got loose, because again, there's not that much retaining mass around the piston pin. So if you do some homework, you might find that you can take that old powder metal rod and just hone it oversize. You don't even have to put a bushing in, and then you can make that a full floating application.
Okay. And then we're going to get closer here to 10, and we'll wrap it up at 10. Bob, as we talk about 2021 new product introductions, new machinery that's coming on board, and we think of Sunnen, and they have a beautiful showcase on EPARTRADE. I mean, everybody should go to the Sunnen showcase on EPARTRADE, and you got a lot to go over, including technical papers and videos and everything. Is there something that's either kind of been new at Sunnen or is about to be new that you could talk about when it comes to machinery, and especially when it comes to race engine builders?
Probably, again, we're looking at different processes on our honing machines and what we can do to make it better. There's, for example, on our SV30, which has been evolving over the years with the different things that we can turn on and we can turn off, that is very, very critical to the racing engine today. And again, we're looking at some tooling that would be give better geometry. We're looking at our abrasives, all those things, and Sunnen is always on top of that, and always testing and trying to find, for the use of a better word, a better mousetrap. Okay. Honing isn't what it was back in 1928, 29, when Joe Sunnen first started his company. It's evolved, and it's going to continue to evolve as things come down the line. And that's the best I could, I can say for right now. Otherwise, I'd have to give away trade secrets.
We can't have that. We'll go viral.
Yeah, that's right.
And then, the shop owner thinks about buying a machine, a piece of machinery to fill a need. But it seems like as he's shopping around for machinery, he ought to really learn also what's the training program or process that goes with it. Bob, do you have any insight on that, any advice?
Oh, absolutely. That's, one of my biggest nemesis out there when I was out there calling on customers is, you give them a lot of information about your machine and everything, and then they go out and buy a used one and expect you to train them for free. That don't happen. That's not the real world. you need to have that training. That is so critical today because, again, there's so many different variables as far as, you know, what's in the computer. We're computer drive units, obviously. And that training is not just about learning to hone. It's about learning to use that machine. Would not sell any machine out there that didn't include some kind of training with it. And again, you know, the automotive is good, but remember, we have an industrial side of our business, and that industrial side, I mean, we're talking about maybe doing 50,000 widgets, and the training on that is very, very critical. So we learn from the industrial world and we bring it over to the performance world to help you understand it better.
So. And Chuck, the AERA is kind of all about training, is that right?
Absolutely, and I actually head up that effort, whether I go on site and work with the equipment suppliers as well, because they're members of the association as well. So my first thing to do is to reach out and say, hey, here's my scenario. Do you want to take this, or should I represent the cause? And so we work very closely together. But yes, I do some on-site training. I've been out several times this year, and even with COVID, you know, but we've still made it work in the areas where we could make it work.
Very cool. Here's a question from the audience. Do you have any comments in regard to irregularity in cylinder finish resulting from finishing a cylinder with a brush rather than a fine grit stone?
You very well could have a little bit of irregularity with that. And again, it depends on the tool that the brush is in. You know, some people use brushes on the end of a drill. Now the end of a drill is going to be far different than actually putting a brush in a tool. So there's where you really get some variables. All right. Versus a fine grit stone. Now, with the thing with a brush is you're not going to remove material with a brush. With a fine grit stone, I don't care how fine it is, you can remove some material. So you got to take all those things into consideration before you go attempting to change your process. But again, you need to look at your process. You need to measure, and see what it's doing.
Very good. Chuck?
Right. The procedural documentation, at what load, how many strokes, and you know, that's the stuff that's a challenge with the older machines. The new CNC machines take a lot of that out of the equation for you. There's actually even dual stage hone heads that have two different abrasives in, or you could have run an abrasive and a brush and take those things, that decision making part of it out. Now, people still tend to do things like interrupt cycles so that they can check something, say they just needed to, I want to take that last tenth or two, and they won't let the thing go through the full automation cycle and interrupt. So, I mean, it's really about having a good process that that works. As Bob mentioned, the brushes is really to clean. You should really have your patented process down, and then the brush is going to get rid of torn and folded materials and wipe out the valleys. And, that's the design intention there. It's not supposed to be your honing process. I mean, it should be the process to the end of the process, but you want to establish your finish with your abrasives.
Okay. Yeah. And I just want to ask a question about the tooling. So do you have any best advice and maybe fix some errors that you've seen out there, especially in the race engine business, for the care and management of tooling? Bob?
Well, very, very important with tooling. Keep it clean. I mean, if you don't keep it clean, it's not going to work right. Remember that tooling is just as high a precision as what you're trying to create. And if you got a tool that's dirty, you're not going to create precision. Okay, so that's number one and most important, is to keep the tooling clean all the time. Obviously there's different types of tooling. as to what you're trying to accomplish with it. And again, that's where our application engineers that are at Sun & Products can help you through that process and choose the correct tooling for your needs. So those are the two fine points I believe about tooling.
Very good. Chuck?
The one thing that I think I would add, and Bob can really appreciate this, is filtration. Whether it's the mats that lay in the bottom of your home, your filters on the system, if you want to add filtration, pressure differential gauges so that you can see how well your filtration is working, because that same abrasive media that you're using to break down your cylinder is still traveling through your hone head and every other component, universal joints, the shoes, the feed cones, everything else is being exposed to that as well. So filter, clean, clean, clean.
Yeah.
Okay, another question from the audience. What can you do if a block should be decked and its numbers matching and the owner doesn't want the numbers removed?
You can take that one, Chuck.
Okay. You can get pretty crafty. Even if you have a big fly cutter, mill as far as you can, and then you're probably going to have to do another setup and maybe use a small end mill or something of that nature in like a Bridgeport. If you're using it like a CNC machine, then you can just choose a smaller end mill or fly cutter or something and make multiple passes to get all the way across that deck and then leave those numbers. If you want to give me a call on the tech line, I've been put in that position quite a few times in my career. There's a lot of like DZ302 or something like that, hey, that Camaro is matched and I want to make sure this stuff's all matching. So you got to get pretty crafty on how to save that, make it look good enough that, it doesn't detract from the value of the vehicle. So yeah, good question.
Yeah.
And then if somebody is listening and they haven't really evaluated their honing program in years, what's the biggest change or advance in the past 5 or 10 years that should make them reconsider what they're doing? Bob?
Material applications. There's obviously the rings, the block, all those things have changed. And I mean, you just look at what's happened in the computer world and how fast we change. You can buy a computer tomorrow and be out of date next year or even before then. We have a lot of people out there, engineers out there, that want to recreate the wheel. And that's always going to happen. So you have to stay on top of it if you're going to stay in business. It's that simple.
Yeah. Chuck, that makes sense to me. Anything to add there?
Just some, for examples, how the race world stuff has introduced itself into the common aftermarket, or, the products that we see every day. In 2010, the 6.4 Navistar went from an iron block to a compacted graphite. The 6.7 Cummins is compacted graphite. The 2.7 liter EcoBoost is compacted graphite. So we're going to have plenty of opportunities to be working on high performance materials. And, as Bob mentioned, processes, nail your processes. And then if there's some opportunity to do something, look at your honing. These controls on the machines now take a lot of this, as we mentioned earlier, they do minimize the things you have to do. Hey, what about this part of the equation? I used a roughing abrasive, and then I went to a thinning or a medium abrasive. Now my finish abrasive. Well, okay, so I need that to be at 15% load and I need to do 5 strokes. Well, this thing's going to count all of that for me. I don't have to, did I hit the bottom? Did I watch that light flash 5 times? It takes that out of it. That's a real challenge that can be, it's not going to go away because there's always, Murphy exists, right? We're in the mechanical parts world, Murphy exists. And, when you look at processes, you got man, method, machine. And as long as a man's touching it, there's opportunity for Murphy to come in. And, but it can really improve the end result with a repeatable process and the electronics to help support that.
Okay. You know, we're getting to right at 10 a.m. and we try to wrap these things up in an hour so everybody can get back to work, and we could talk to you for another couple hours on this subject. This has been great. Thank you so much. And then any parting words of wisdom when it comes to strategies for machining a race engine? Bob?
I would only say again, I'll reiterate what I've said, and that is applications. Learn how to set your process up. Take the time to evaluate your process. That's very, very important. If you do that and you do your homework, you'll be a winner.
Thank you, Bob. Chuck?
Mm-hmm.
You know, I'm going to steal some Franklin Covey stuff here. Begin with the end in mind. You know, have a plan for where you want to be. And then, you know, once you know what you're looking for, then, okay, the right surface finish for those DLC coated rings. How flat does this thing need to be? What's the surface roughness? Because I'm going to use MLS gaskets. I'm going to use such piston or whatever. You know, so know where you want to end up. These guys are, they're crafty and they're thinkers, and they'll do their research. And so that's the biggest thing. Just know where you want to be, I think.
Very good. I should have enjoyed this, guys. Thank you so much for sharing your time and your insight and your history with us. Looking ahead, again, Online Race Industry Week, November 30th to December 4th. Do us a favor, go online and register for the single Zoom login. That'll take you through the whole week at no charge. Sunnen is participating, so you can see a new product line from Sunnen on EPARTRADE. You can go to it now and see what they have, and it's really one of the best showcases on EPARTRADE. So that wraps it up for our seminar on machining strategies for race engines. Thank you, Bob. Thank you, Chuck. Thank you, Sunnen. And we'll see you again next time.
Okay. Thank you.
All right.
Thank you.